Grade 12 cubic functions. Grade 12 cubic functions. Examination questions. Here is an example of an exam question on cubic functions. Studying is necessary in maths because the moment you look at a question, you need to know immediately what to do. Let's look at this question. Number 1.1. Show that x minus 3 is a factor of f of x. If x minus 3 is a factor of f of x, now x minus 3 is a factor of f of x. This is stated. What we need to do is to prove that x minus 3 is a factor of f. Therefore, if x minus 3 is a factor of f of x, it means the value of x is equal to 3 in f of x is equal to 0. So to prove this, you must find f of 3. That means you put 3 in place of x, and the value that you get there must equal 0. That is the proof required to show that x minus 3 is a factor of the expression. Very common question in a lot of examinations. Number 1.2, factorize f of x fully and hence solve for x if f of x is equal to 0. In number 1.2, we are using the factor that we got in 1.1. We have already been given one factor, so using that one factor, we can apply various methods to solve number 1.2. Factorization can be done using log division. It can also be done using synthetic division. You are not restricted on this one. You can use any method of your choice, but the development is from the factor that we got in 1.1. Number 1.3, the information we need here, or the knowledge we need, is that at the maximum or minimum, the derivative is always equal to 0. So what we do here is that we differentiate the expression and we equate the derivative to 0 and solve for x. That will give us the values of x that are needed to determine the coordinates of the minimum and the maximum. Then number 1.4, determine the coordinates of the point of inflection. At the point of inflection, the second derivative is always equal to 0. So what we do here is that we differentiate the equation twice to get the second derivative. Then we equate the second derivative to 0 and solve for x. That will give us the x coordinate of the point of inflection of the function. Then once that information is gathered, we have the intercepts from number 1.2, and we have the turning points from 1.3. Number 1.2, number 1.3, the information we get from these two is what we need to be able to draw this graph. Once that's done, then the graph can be constructed and everything else can be answered. All right, let's have a look at the answers to these questions. Question number 1.1. Show that x minus 3 is a factor of f of x, and f of x is the equation given. So to do this, we have already explained. Simply substitute x with 3 and the answer that we get must be 0. That is the proof required. If x minus 3 is a factor of f of x, it follows that f of 3 must equal to 0. That means replace x with 3 and simplify. The answer must be 0. Number 1.2. Now we can factorize number 1.2 using various methods. In this case, we have used the synthetic division to simplify this. Now synthetic division works like this. The first value, this one here, that is the value of 3 that we have used in number 1.1. Then these 1, 2, 3, 4 numbers, they are the coefficients of the expression we are factorizing. The coefficient of x cubed is 1. The coefficient of x is negative 3. So it's 1, negative 3, negative 1, and positive 3 is the constant. There are these four numbers. They are the ones that we have here in the top line. Then we draw a line across and then do our division. The first value, you bring it down as it is. Then you multiply 3 times 1. The answer that you get, you write it under the next column. Then the two numbers, you add them and write the answer at the bottom. Then you multiply again 3 times 0. The answer that you get, you write it under the next column and you add these numbers to get minus 1. Then you multiply again 3 times negative 1. The answer that you get, you write it under the next column. Then you add these numbers to get 0. If this number that you are using here is a factor, like you proved in number 1.1, then the last number that you get here, definitely it must be 0. Now, once we are done doing that, this value is the value of A, this is the value of B, this is the value of C in ax squared plus bx plus c. So these numbers are coefficients of the quadratic factor that we get. So after that, we can carry on to factorize our expression. The first factor is the one that the question gave us, x minus 3. And then this is x squared minus 1 because b is 0. Then we can further factorize this as a difference of two squares here to get these two brackets. Then our expression has been fully factorized. Where the question says solve for x if f of x is equal to 0, we are simply equating the equation that we have factorized to 0 to get the values of x. So that's number 1.2. Solve the first bracket can safely give us x is equal to 3. The second bracket can give us x is equal to 1. And the next bracket can give us x is equal to negative 1. Now we are left with number 1.3, which says find the derivative of f of x and hence the coordinates of the stationary points. We know that the coordinates of the stationary points come from equating the derivative to 0. So we differentiate the expression and equate the derivative to 0. If you differentiate a cubic function, you get a quadratic function. So if you then equate it to 0, it produces a quadratic equation that you can solve by a quadratic formula, by factorization, by completing the square, any method that you are comfortable with. When you get the values of x like I did here, I need the values of y. The values of y come from the original equation, not from the derivative, but from the original equation. So we substitute these two. We put 2,15 in place of x in the original function. That will give us the value of y, and that gives us the coordinates of one stationary point. Then we substitute x with negative 0,15 in the original equation and simplify. That will give us the coordinates of the next turning point. Now the coordinates of the turning points have been calculated in number 1.3 and the question is answered. Question number 1.4, determine the coordinates of the point of inflection. The point of inflection is found by equating the second derivative to 0. That means you differentiate your expression 2 times. Then the second derivative that you get, you equate it to 0 and solve for x. So in our case, we differentiate f of x to get the second derivative, the first derivative. Then we differentiate again to get the second derivative. Then equate the second derivative to 0 and solve for x. That's how we get x is equal to 1. Then we substitute this value of x into the equation to get the value of y. So it means the coordinates of the point of inflection are 1 and 0 in brackets. These are the coordinates. Now, if you are in an exam situation, just to be fast, you can differentiate directly the second one, because we did the first derivative when we were calculating the coordinates of the turning points in number 1.3. So you can take your derivative from 1.3 and differentiate it the second time to get the second derivative. Then equate the second derivative to 0 to determine the values of x. So the point of inflection, you differentiate 2 times and equate the second derivative to 0. That is what we do. So this question has got these concepts that we have explained. The next thing that we need to do here is to sketch the graph of this function. Now that we have put together the information we need, we can safely draw the graph. The x-intercepts, we have calculated them in question number 1.2. So let's indicate that one on the graph. X is equal to 3, x is equal to 1, and x is equal to -1. Then we need the turning points. This is the first one here, minus 0,15 and 3.08, and 2,15 and minus 3.08. Those are my 2 turning points. Now, once I get the turning points and the intercepts, I can safely connect my graph from those points, from the intercepts to the turning points, and so on. This is the graph for the given function. Then I have answered number 1.5. Just to emphasize again, it is absolutely necessary to make sure the x-intercepts are correct and the turning points are correct, because once we make a mistake in those ones, it will become impossible to draw this graph correctly. Now, when a graph is drawn, just to add more information, even though it is not given here, the graph is increasing on one side because it is going up. So we say the gradient or the derivative for the function is greater than 0. It is positive. At the turning point here, the derivative, which is the gradient, is equal to 0. That is why we equate the derivative to 0 when calculating the coordinates of the turning point. Then from in between here, the graph is decreasing, so the derivative of the function is less than 0. When we reach the next turning point, the derivative, which is the gradient, is equal to 0. Then going upwards, the derivative once again is greater than 0 because the graph is increasing. So in some examinations, the question can say to you, find what are the values or value of x. Determine the values of x for which f of x is increasing or decreasing, whatever the case may be. Then I must look at my graph and determine which part of the graph is decreasing, which part of the graph is increasing. Mine is decreasing from one turning point. That point there, the x value is negative 0,15. And it is decreasing from negative 0,15 up to the next turning point, which is 2,15. From negative 0,15 to 2,15. In between this, the graph is decreasing or the gradient is negative. We may also want to emphasize the concavity of the function. In this graph, we did calculate the point of inflection, which is 1, 0. The point of inflection, this is the point where the graph changes its concavity. So, should we ask you what is the significance of the point of inflection? This is the point where the graph changes its concavity from concave up to concave down, or from concave down to concave up. Our function is done. Nice and cute. There is no stories this one. This is cubic functions, grade 12 mathematics, paper 1.